Hey everybody, welcome back. This is Professor Hank, and in this video I'm going to give you another example of how the linker does its business, right? So this example will be a little bit more involved. In a previous video I showed you an example where we had two object files that got combined into a single executable. In this video we will do three object files, right, with some different code or parameters. Okay, so let's begin. So let's review. First of all, what is a linker? What is an object file? What the heck is going on? Right. So during the translation process, right, you have source code in a high-level language such as C, right, and that code gets fed into a compiler program. Okay, and that compiler program outputs an assembly program. Okay, assembly program, and from there that assembly program gets input into an assembler program, right? And I probably should say assembly source, right? You get the assembly source code for a program, okay? And then that source, similar to how the C source was fed into the compiler, the assembly source gets fed into an assembler program, and the assembler program assembles that source code, and the output of that is an object file, okay? And if you have multiple object files because maybe your program had multiple C source code files, for example, right? Maybe you had a bunch of headers that you wrote on your own, or maybe you were including some code from the standard template library, then you could end up with multiple object files, right? So if you have multiple object files, then those guys have to be combined into a single executable program, right? And so the executable program is that file that gets created is what you would double click on to run your code, right? So it contains all of the machine instructions and data that your program needs to do its thing, right? So we go from source code to the compiler program. The compiler program spits out assembly source code, and then that assembly source code gets fed into a assembler program, and then the assembler program runs and spits out an object file. Okay, now object files are made up of a few different things, right? So we've got, as part of an object file, we have an object header that is going to provide some information about what's inside this object file itself, right? So this object file has got a bunch of machine instructions that, if you're not combining with any other object file, no problem, right? You're just going to go straight to an executable program file, right? But if you've got multiple object files, and let's say that object file A is calling procedures in object file B, right? Well, we have to resolve those memory addresses, right? So if you've got an object file just by itself, okay, and it goes straight to executable, well then the first instruction, the text segment, is going to be at 400,000 hex. Okay, fine, right? But if I've got two different object files, they've both got their own sets of instructions, so we have some issues, right? So in object file A, if it's calling a procedure in B, well, what's that memory address for the procedures, right, where it starts? But here's another thing. The first instruction object file A, the first instruction object file B, they both can't go at 400,000 hex in memory, right? So one's got to come after the other. Okay, so these kinds of issues are what the linker program is for. Right? So the linker program is responsible for combining all the object files into the executable file, resolving any of these conflicting or missing memory addresses. Okay, so an object file has got a few pieces to it, right? It has essentially the instructions, it's got the data, it also has some header information that specifies, well, how many bytes is the text segment, how many bytes is the data segment. In addition to that, it has some relocation information, which is used to stitch all of the object files together, and it's got this symbol table, which is going to be pairs of symbols, like variable names, procedure names, and memory addresses. Okay, so once the linker finishes stitching all of these object files together, you get that executable with all the memory addresses resolved, all the instructions in their correct place. An executable file is basically just an object file without any unresolved memory addresses. Okay, so let's go ahead and start digging into the example. Okay, so let me clear my canvas here, and let's say that I've got, instead of 2 object files like we had in previous example, let's say that I've got 3. Okay, I'll try to fit this all onto one screen. Okay, if not, I might have to, try to split it up, but we'll see how it goes. Okay, so object file 1 has a procedure named procedure A. Okay, and I'll just say proc A for short. Object file 2 has got a procedure named procedure B, and object file 3 has got a procedure named procedure C. Okay, and so those are the names of procedures. Okay, and in addition to the object files having those names set aside, each object file is going to know how big its text segment is, right? So in this example, let's say that object file 1 has a text segment that's going to require 200 hex worth of instructions. Let's say that object file 2 has got 450 hex worth of instructions, and object file 3 has 380 hex worth of instructions, right? So by that I mean 380 hex bytes worth of instructions. Okay, all right, now in addition, there's going to be a data segment for each one of these files. So let's say that A has got a data segment that requires 72 hex bytes worth of memory. Let's say that object file 2 requires 24, and object file 3 requires 12. Okay. All right, so now let's put together text segments for each one of these files. Okay. Now, keep in mind that inside the object files themselves, everything's just ones and zeros, bits, binary, right? So, there isn't going to be, proc A, proc B, proc C, and right here for the text segment, I'm going to go ahead, just like the text does, and write out the instructions, right, rather than writing everything in zeros or ones, just so it's easier for everybody. Okay, so let's say that the text segment for object file 1, that guy's going to start at 0 hex, okay, or 0 bytes away from the beginning of the text segment for that file. Okay, and let's say that there is a jump and link instruction starting that. Okay, now that's going to have to go to that jump and link instruction is going to need a memory address to go with it, but we don't know what it is just yet because we haven't linked the object files together. So this address, this jump and link address, is going to end up jumping to procedure B. Okay, but more on that later. Okay, so let's say that there's some words worth of instructions that don't require memory addresses to be resolved, and let's say that the next instruction that does require it is 48 hex away from the beginning of the text segment, and we'll say that that instruction is a load word instruction that's trying to load something into register S0 from a place in memory. I'm going to run out of space here. And remember, the memory address is going to be relative, right? So MIPS uses the global pointer, what it's initialized to be able to locate things relative to each other. Okay? All right, so then the rest of the text segment, the rest of the memory with its instructions has instructions that don't require any memory addresses to be resolved. So we'll just let the dots represent that. Okay. Now for object file 2, okay, it's going to have, starting at its text segment, a load instruction trying to load something into A0 that is going to be a certain distance away from the global pointer. Okay. The next instruction after that is going to be another load instruction into the A1 register that's a certain distance away from the GP register. And then the instruction after that is going to be a jump and link. Okay. That's going to end up jumping to the C procedure in object file 3. Okay. And then the rest of the memory is used up by instructions that don't require resolution of memory addresses. Okay, so let's look at object file 3, and the first 128 hex worth of memory addresses of instructions don't require any address resolution, but at 128 hex we're going to have a store word instruction that's going to take what's inside of A0 and then place it into memory that is a certain distance away from that address in the GP register. Okay, and then the rest of the memory space, the rest of the instructions don't require any kind of address resolution. Okay, so that is the text segments for each of the object files. Now what about the data segments? Okay, all right, so the object file 1, starting at the beginning of its data segment, there's going to be a chunk of memory which we'll refer to as X. Okay, and it's going to use up all 72 hex worth of memory for object file 1's data segment. Okay, so in object file 2, at the beginning of its data segment, there is a chunk of memory being used that we'll call Y, and it's going to require 12 hex worth of memory. So there's going to be another chunk of memory, distinct, another variable, another array, that's going to be, that we'll call Z, that's going to start 12 hex after Y begins, right? So where Y ends, Z begins. and then Z is going to take up the rest of the 12 hex worth of memory. Right? So Y takes up 12, Z takes up 12 hex worth of memory. Now for object file 3, it's going to have, starting at the beginning of its data segment, a single array, say, that we'll call W, and that thing is going to be 12 hex long. Okay? So that is our data segment for the 3 files. Okay? Now, let's take a look at the relocation information for each one of these object files. Okay, let me scroll up here a little bit. Okay, so what's this? Right? So what this is doing is this guy right here is laying out dependencies, right? So the jump and link instruction, which starts at the beginning of the text segment for object file 1, is jumping to B, procedure B, in object file 2. Okay, its load word instruction, which is at 48 hex, away from the beginning of the data segment, that guy is trying to load data from the X array. Okay. All right. So, what about object file 2? Okay. Well, the load word instruction, that's 0 bytes away from the beginning of the text segment, is depending on Y, right? And the load word that's 4 hex away from the beginning, that is depending on Z. And then that jump and link instruction that is at 8 hex away from the beginning of the data segment, well, that's depending on procedure C in object file 3. Okay, now object file 3 has a single unresolved store word instruction 128 hex away from the beginning of its text segment, and it's depending on the item in its data segment called W. So that's the relocation info. Okay, last thing is symbol table. Okay, so the symbol table is a list of all the things that you're depending on. Right? So object file 1 is depending on X and B. Object file 2 needs to resolve Y, Z, and procedure C. And then object file 3 needs to resolve W. Okay? So now we need to combine these 3 object files into a single executable, right? The linker is going to be going through and doing this, right? So what we'll do is it's going to have to combine all of these text segments, it's going to have to combine all of these data segments, it's going to have to figure out the overall text size, overall data size, and where everything is in relation to each other. Okay? So now a couple of facts to remember. Instructions in a executable MIPS program begin at 400,000 hex, right? So that is where your first instruction is. Okay, and the GP register gets initialized to 1,008,000 hex, right, which is right in the middle. It's the middle address of the data segment, and the data segment begins at 1 million hex. Okay, so we can use that information combined with the object file header information to create our executable. We're going to act as the linker here. Okay, so let me see if I can drag this over here. We'll make some room. All right, so the executable, that's going to be built out of those three object files, is going to start with object file 1, object file 2, object file 3. So 2 is going to get appended to 1, 3 will get appended to 2. Okay, so what's going to be the size of the text segment? Okay, well, we just simply add up the text size, the segment size of all three of the object files. So 200 plus 450 plus 380. Okay, so what's that going to be? It's going to be 1030 hex. Okay, so let's go fill that out. Okay, so the text segment size is going to be 1030 hex. Similarly, for the data segment size, okay, what's it going to be? Go back, add up the data segment sizes of all three object files. Okay, so our new executable is going to have a data segment size, right? Or a data segment that's going to require, I should say, 108 hex worth of data, right? So the text segment's going to require 1030 hex bytes worth of instructions. Data segment's going to require 108 hex bytes worth of instructions. Okay, so now what we have to do is we got to combine those text segments together, right? And then we're going to have to combine those data segments together, and then we're going to have to fill in missing memory addresses for everybody. Okay, so let's do the text segment. Okay, so the text segment is going to start off with the first instruction from object file 1, right, which was a jump and leak instruction. Okay, so that's going to start off at the beginning of our executables text segment, which again is 400,000 hex. That's where that memory address is. That's that memory address for the first instruction. So it's a jump and link instruction, right? Now we don't know where just yet we're going to be jumping to. We're going to figure that out as we go. So I'll leave this blank so we can fill it in. Okay. So what was the next instruction? Well, the next instruction that required resolving the memory address was 48 bytes or 48 hex bytes later, right? There were instructions in between that didn't need any extra special intention, right? So the next instruction that needs memory addresses dealt with was at 400,048 hex, and that was the load word instruction. Okay, so load word into S0, and that's going to be a certain distance away from the GP register, right? Because we're loading some data from the data segment, and so we're going to have to figure out where that is exactly, and we're going to use the GP register to do it. Okay, so after that, we've got the rest of the instructions for the text segment from that object file that don't need any special attention. Okay, so that takes care of the text segment from object file 1. Now let's look at the text segment from object file 2. Now at the beginning of its text segment, we got a load word instruction. we got another load word instruction and a jump instruction. Okay, so what's the memory address of this first instruction going to be? Well, it's going to be 200 bytes away from the beginning of where, or 200 hex bytes worth, I should say, away from the beginning of where the text segment of the object file 1 began, right? So 400,200 hex, right? Why? Because remember, the text segment for object file 1 was 200 hex. That's why. Okay, so we had a couple of load word instructions. Okay, so let's fill those in. So we got load word into A0, some distance away from the GP register. Next instruction in object file 2's text segment was another load word, and it was going into register A1, some distance away from the GP register. Now, what's the memory address for this? 204 hex, because each instruction, one word long, so 4 bytes. Okay, so after that, we have a jump and link instruction, one word later, right? So what's the memory address of that going to be? 400,208, right? And we're going to have to fill in the memory address of where we're jumping to. Okay, now we've got a lot more instructions as part of the text segment that we're bringing in from object file 2 that don't need any address resolution, right? So remember, the text segment was 450 hex long for object file 16. Therefore, the beginning of the text segment for object file 3 is going to be 450 hex after the beginning of the text segment for object file 2. So that's going to be 650, A16, right? So this stuff right here was all from the text segment of object file 2, and it was 450 hex long. Okay, so now let's go look at the text segment for object file 3. Now, the first instruction that requires any kind of address resolution was 128 hex away from the beginning of its text segment. So that means that there's a bunch of instructions in between the very beginning of that text segment and when we actually need to have the linker do any work. So it was 128 hex away from the beginning of the segment. So that's 778, 16, right? So a bunch of instructions until this one that needs resolution. And it is a store word instruction into A0. Okay, so store word into A0, a certain distance away from the address in the GP register. Okay, so that is the text segment for object file 3, which was 380 hex long, right? Okay. All right, so then we've got much space, right, until we get to the beginning of our data segment, right? So where does the data segment begin? 1 million hex. Okay, so this right here, this beginning part was everything that goes into the text segment, and so now this part is everything that goes into the data segment. Okay, So what's going first? What's in the data? What's the first thing in the data segment? Let's go back and look at object file 1, right? So what was in its data segment? We had this chunk of memory that we're referring to as X, and it starts at the very beginning of the data segment for object file 1. So guess where it's going? At the very beginning of the data segment for our executable. Okay. Now, did we have any other variables or anything else in the data segment? No. So let's plug in the stuff for object file 2, which was Y and Z. Now Y started at the beginning of object file 2's data segment, but that's going to be in our executable 72 hex away from the beginning of the executable's data segment. Why? Because X took up 72 hex worth of memory. 72 hex worth of memory. Okay, so let's go back over here and plug in Y. So Y is going to be at 72x. Okay, 1,072,000. So there was a Z also. In that Z in object file 2 started 12 hex away from the beginning of object file 2's data segment. So it needs to come 12 hex after the beginning or after the start of the Y chunk of memory. Okay, so let's plug that in. So it's 12, right? So this is going to be 84. So this is where Z begins. Okay, so data segment for object file 1 and 2 both accounted for. Now let's go account for object file 3's. Now object file 3 has just got, oops, let me fix that. Object file 3 has just got this W variable. Okay, now where is it going to begin? Well, it has to start 24 hex after Y, right? Now Z starts 12 after Y, so then our W has to start 12 after Z, right? Because the data segment for object file 2 is 24, Y starts at the beginning, so it's 12, Z starts at 12, and so there's 12 left. So W from object file 3 is going to start 24 after Y. So let's go back and plug that in. Okay. Alright. So 96. So that's where our W goes. Okay. So the X was the data segment for object file 1. The Y and Z data segment for object file 2, and the W data segment for object file 3. Okay, so now all that's left for us to do is go back and plug in the memory addresses that we left for later, right? So what about this jump in link instruction at the very beginning of the text segment of our executable? Oops. Well, let's go check the dependencies, right? Let's go take a look at the relocation info. So we can see that in object file, stop that. We can see that in object file 1, that jump and link instruction is jumping to procedure B. Now where does procedure B begin in the executable? Right? Begins right at 400,200 hex, because that was the beginning, right? As we walk through, that's the beginning of the object file text segment, right? So let's plug that in. Okay, now let's do the other jump and link instruction, which was part of object file 2. Okay, in object file 2's jump and link was depending on C, procedure C, which is the beginning of the text segment for object file 3. Okay, Now that began at address 400,650 hex. So we'll plug that in. Okay, so all we have left to do now is plug in the memory addresses for those load and store instructions. Okay, so this is kind of the tricky part, right? So remember, the GP register gets initialized to 1,008,000 hex, right? So that is the address that's right in the middle of the static data segment, okay, for the executable. So what we got to do is we have to find an offset. So that number right there, that address right there, is going to be our base address, and so we need an offset. Okay, so for the first load instruction, that was depending on what? Let's go back and look. Okay, that was depending on X according to the relocation info portion of the object file header. So where's X in memory? X is at 1 million. So the address that we need to derive for this load word instruction has to be 1 million, right? But remember, GP is 1,008,000. So what do we need? We need an offset of minus 8,000, right? Minus 8,000 plus 1,008,000 gives you what? A million. Gets us our X. Okay. So similarly, we're going to do the exact same thing for the other guys. Okay. So where does, or what's this load word instruction, the second load word instruction, trying to reference? Go back and look at the relocation info. Y. The third one's doing Z, and then the store instructions doing W, right? So I forgot to write the SW in there, so I'll do it right now. Right? So this should be SW, right? Because it matches the instruction right there. Okay, anyway, so Y is where? 1,072,000. So we have to find the difference between 1,008,000 and 1,072,000. Okay, I'm just going to do it in my head. So if I'm off, you know, be aware I'm doing this in my head. Okay, we got to find the difference though. So it's going to be minus 7,928. Right? That should give me 1,072,000. Now this second load word instruction needs the Z. So that should be minus 7,916. And then finally, the store word instruction needs to get to 1,096,000, right? So that should be minus 7,904. Again, why? Because 1,008,000 plus minus 7,904 is equal to 1,096,000 hex. Okay. All right. So there you go. Right. So previous video you had a much. Let me just see if I can zoom out here a little bit. In the previous video you had a much simpler example just to get you started. Okay. So in this video we've got quite a bit more going on, a little bit more in-depth explanation, but that's how it goes. I mean, that's how it works. That's what the linker is doing, right? That linker is combining object files into one executable file. Once you have your executable file, the loader then takes your executable file, puts it into memory, and starts it running. Alrighty, thanks for watching, and I hope you found that helpful. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up and If you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.